Hello, Legacy students. So today I am at a meeting. So what I planned on doing is going through two full examples from your worksheet that are today. So you want to make sure you grab out your worksheet or grab the worksheet from my sub. We're going to do number 6 and number 7 together. So you should turn to number 6 first. The problem that I'm looking at is 2x minus 1 over x plus 4. So remember, guys, S stands for simplify. So that means if I can factor the top and factor the bottom, I need to do so. Notice, guys, can't factor the top, right? So it's going to be 2x minus 1. But I can factor the bottom, so that's x plus 4. Or I can't factor the bottom either. So the simplified version is basically the equation. H stood for wholes. Wholes is if stuff cancels off. So if I look here, nothing's going to cancel off. So I'm going to put none there. R stands for your roots. AKA, what you're going to want to do is set the numerator equal to 0. So I'm going to set the numerator here equal to 0. Solve. I'll get x is 1/2. Now remember, your roots are also your x-intercepts. So what I'm going to do is go 1/2, comma 0. Those are your roots. So I'm going to want to put a dot at 1/2, comma 0. Right there. Asymptotes are the denominator equal to 0. So I'm going to set x plus 4 equal to 0. So I know x is negative 4. Graph that here. It's a line at negative 4 that goes up and down. There we go. So t squared, remember t squared stands for tangency and together. Tangency is if you have duplicates in the numerator. So that would be like if I had 2x minus 1 twice in the numerator. So I have no tangency. And togetherness is if you have duplicates in the denominator, which in this case is another no. So those two, I do not have tangency, so that means all of my x-intercepts, I'm going to go through them. Togetherness means at the one asymptote I have, the one vertical asymptote, I am going to go different directions on both sides. One side's going to go up, one side's going to go down. End behaviors when we have to look at our paper. We have to look at the degrees of the numerator. So I'm going to make a little note. The degree of the numerator is a 1, right? Because it's x to the first. And the degree of the denominator is an x to the first. So then I have that the degree of the denominator and the degree of the numerator are equal. So I got equal here. So if I look on my paper, it says that if the degree of the numerator is equal to the degree of the denominator, the HA, aka the horizontal asymptote, is equal to the ratio of the leading coefficients. What does that mean? Well, it's going to be y equals the numbers in the front of your problem. That's what it means by leading coefficients. Ratio is just a fancy word for fraction. So it's going to be 2 over 1, or 2. So I'm going to make my asymptote at y equals 2. Like that. Crosses is when we set the end behavior asymptote, so 2. I'm just going to put it over 1, so it's a fraction, equal to the simplified version. So let's set the simplified version up. There we go. Let's cross multiply. So that's 2x plus 8 equals 2x minus 1. Subtract 2x. You get 8 equals negative 1, which tells me that I will not cross the horizontal asymptote on this particular problem. Y-intercept, I need to plug 0 in for x. So I'll get negative 1 over 4, right? Because this is 0 minus 1, 0 plus 4. So that tells me I have a y-intercept of negative 1/4. So like right about there. Okay, here's when we start to get to draw our graph. So I know I have to go through my 2 red dots, right? So I have to go through these 2 dots. Can't cross this horizontal asymptote because we found we do not have a cross. So I know that I need to just kind of hug that line, slowly and surely curve to hit my 2 dots, my x-intercept and my y-intercept, and then I can't cross the vertical asymptote here. So I gotta draw, just slope down as I get close. Now I need to have another boomerang here. Can't have it down here, because if I have it down here, that would mean I'm together. And we found we're not together. We didn't have duplicates in the denominator. So I can't go here because that means it would be both going the same direction. Never will you have a graph stacked on top of a graph, because that's not a function. The vertical line test states that if I have one vertical line that can cross the graph twice, that's not a function. And these are all functions. So it tells me that I have to have a graph up there. Doesn't cross that line, doesn't cross that line. Now let's do our domain and our range. So if I look at my domain, that tells me negative 4 is the only x value I can have, right? So I'm going to write it as negative infinity to negative 4, parenthesis, because I can't touch negative 4, and then negative 4 to infinity. Range, the only y value I can't have is 2. So negative infinity to 2, 2 to infinity. Let's try number 7 now. So flip to number 7, should be on the same page, I believe. Oh, no, different pages. Let's first do our S. So I can't simplify the top, but I can simplify the bottom. It's x squared minus 6x plus 9. 2 numbers multiply to give me 9, but add together to give me negative 6. Multiply to give me 9. 9 and 1. Oh, negative 3 and negative 3. That will give me a negative 6. So that means x minus 3 would be my denominators. No holes. Nobody crosses off. Ruts. Remember we set the numerator equal to 0. So 5 equals 0. 5 can't equal 0. So that means we do not have any ruts in particular. A is for asymptote. That's the denominator set equal. So in this case, x equals 3 is one of my asymptotes. Draw that in here quick. There we go. No tangency, because we don't have duplicates in the top. The one thing I do notice, do you see how, guys, we have the same denominator? There's 2 things in the denominator that look exactly like one another. That's togetherness. So this tells me that at that asymptote, because that's what was duplicated, that tells me that at this asymptote I have, if this side goes down, or if this side, the left side goes to negative infinity, then the right side also has to go to negative infinity, and vice versa. So if the left side goes to infinity, the right side also has to go to infinity. We'll figure that out, which way does it go, once we start getting some more information on our graph. So E is for M behavior, so we're going to find the degree of the numerator and the degree of the denominator first. So degree of the numerator. Remember, degree is always attached to an x. If there's not an x, well then that tells me I have a degree of 0 in the numerator. No x's, degree of 0. Degree of the denominator, however, be very careful. It would actually be an x squared, because if I multiply the x by the x, I'll get an x squared. So the degree of the denominator is 2. So I have a degree of 0 in the numerator, degree of 2 in the denominator. That tells me that, if I look at my yellow page here, tells me I have a degree, that means I'm bottom heavy. So let's put that in there. Bottom heavy. And it tells me that if I am bottom heavy, I have a horizontal asymptote at y equals 0. So let's go ahead and graph that here quick. At y equals 0. There we go. C is for crosses, so we're going to set it equal to the equal to the end behavior, the horizontal asymptote. So 0 over 1 equals the simplified version, like that. If we cross multiply, we'll get 0 times that, which is 0. 1 times 5 is 5. So I get 0 equals 5. Well, that tells me these guys are not going to cross at all. Let's find our y-intercept now. I'm going to plug 0 in for x. Oop, that's a minus. Minus 3. So 5 over negative 3 times negative 3. 5/9? Looks like. So 0, 5/9 would be the y-intercept. So let's graph that dot here. Between 0 and 1 somewhere up there. So now I've graphed everything on my graph. I've gone through Stratasy entirely. So I know I'm not going to cross the y-axis or the x-axis because we didn't have that we crossed the horizontal asymptote. So I know that I have to go through this dot, but then it's just going to slowly kind of taper off there. Can't cross the vertical asymptote, never can. So I'm going to go like that. Now, careful guys, we said we are together at this asymptote. So since this side goes up, this side also has to point up. It can't be down here, because then that would be it pointing down at that asymptote. So I need to go up, like that. So let's do our domain and range here. So my domain, it looks like I can't include 3. So from negative infinity to 3, 3 to infinity. Range, though, is a little different. Notice we don't have any negative y values, so I can't have a negative y. We also can't include 0, but it starts at 0. So 0, parenthesis, because this means saying, hey, I can't start there, but to infinity. And that's the examples for today. What you're going to want to do, guys, you do have a video tonight on slant asymptotes, aka what are you going to do when your end behavior says top heavy. So you're going to definitely want to watch that. Finish the rest of the worksheet. Answer key is posted at the front of the room, so you can definitely take pictures if you want. If you don't finish by the time you're done with class, what you can do is I'll have the answer key post on Classroom for you guys. So that will be at the end of the class period. But please make sure you watch your video tonight, and I will see you tomorrow in class. See you later, Sabers.